All right, so today we're looking at the graphs of rational function. This is going to be the main focus of this unit, for the rest of this unit. So yesterday we found all of this information. We found the vertical asymptotes, the horizontal asymptotes, x-intercepts, y-intercepts. We also found holes. So we're not going to go back over how to find all of these. What we're getting straight into is graphing. So for this first one, I'm going to go ahead and list out all the aspects we need to worry about. And then we'll talk about how we actually graph them. So when we look at this one, we have vertical asymptote at 4, horizontal asymptote at 0. And let's actually write this correctly. There's a vertical asymptote at x equals 4, horizontal asymptote at y equals 0. X-intercept is none. Y-intercept is -5 over -4 comma 0, or 0 comma -5 over -4, so 5 over 4. And no hole. Okay, so I'm going to start by graphing the vertical asymptotes. Vertical asymptotes are dotted lines that are vertical on that x value. So vertical asymptote of x equals 4 means that we're going to have a dotted line at x equals 4. 1, 2, 3, 4. Boom. Vertical asymptote right there. Horizontal asymptote at y equals 0 means that we have a horizontal dotted line at y equals 0. And we have a y-intercept at 0, 5 over 4. So 0, here's 1, 5 over 4 is going to be just above that. Okay. Before we get to graphing, we have to check one last thing. And this is if it crosses the horizontal asymptote. What do I mean by that? Well, we're going to take this horizontal asymptote here of y equals 0, and we're going to plug that in for y. So 0 equals -5 over x minus 4. Now, in future problems, you only have to do this if the horizontal asymptote is not 0. If it is 0, then your x-intercept will answer this question. So we only have to do it if it's not 0, but we'll check it anyway. So to solve this, we're going to cross multiply. So we have 0 equals -5. This is not solvable, so we have nowhere where it crosses the asymptote. The reason we have to check this is because sometimes you'll get a graph that will cross the asymptote and then come back to it. So we're trying to check for anything like that happening, okay? Next thing we want to do is label our asymptotes and our intercepts as even or odd. Now, what does this mean? Well, we look at the factor that gave us this asymptote of x minus 4, and we say, okay, what is the degree of that factor? Well, it's a degree of 1. That means this is an odd asymptote. What an odd asymptote means is that the arrows on either side will be opposite directions. So one will be up and one will be down. So it would either be like that or like this. All right, so that's what we're looking at here. An odd asymptote means that arrows are going in opposite directions. Odd, opposite. Easy way to think about it. If it's even, that means the arrows would go in the same direction. Okay, so even would be the same direction. We also do that for the intercepts, but at this problem we don't have any intercepts, so not an easy one to check. And now we draw. We look to see if we have any points already on the graph. And look at that, we have one right here. We're going to draw an arrow toward the vertical asymptote going up, and an arrow toward the horizontal asymptote going down. Okay, this is our first section of the graph. From here, we use the degrees of the asymptotes to tell us what we're going to be doing. So this is an odd degree asymptote, which means instead of an arrow going up here, we won't have that. We know our arrow is going to go down, and then we're going to approach the horizontal asymptote. And there's our whole graph. Now, this gets a little more complicated once we start including x-intercepts and whether it bounces or crosses and things like that we're going to look at in future problems. Also, once we start including holes and if it crosses the horizontal asymptote. But this is the basic idea, okay? Let's look at another one together. Once again, I'm going to go ahead and find all this information. Y'all should be able to find this from the homeworks yesterday and the lesson yesterday. But I'm going to go ahead and find this stuff. So we have y equals 2 for the vertical asymptote. Horizontal asymptote of x equals 0, or sorry, I read backwards, x equals 2 and y equals 0. X-intercept is none. Y-intercept is -3 over 4, so 0, -3 over 4. Whole is going to be none. And once again, we said if the horizontal asymptote is 0, we do not need to check if it crosses. We already checked that with the x-intercept. And I'll explain what that means when we get to a problem that involves it. All right, so we start by graphing. We have horizontal asymptote at 0, vertical asymptote at 2. Okay. Y-intercept at 0, negative 3 over 4. So there's negative 1, negative 3 over 4 is right about there. And then we'll label this asymptote. This time we have a degree of 2 on our vertical asymptote. So this is going to be even. That means the arrows are going to do the same thing. And as we said, it doesn't cross for this one. So we take this dot, we go one down toward the asymptote, and one across toward the asymptote. And then the even says the arrows are going to go the same direction. And so there's our graph. Once again, once you find all this stuff, it's just going through these steps every time. All right? Now, let's look at one that's a little more involved. Okay? So, we start with the vertical asymptotes. This is anywhere the denominator is equal to 0. That's going to be x equals 1, x equals 3, x equals 5. And let's go ahead and label these now. X equals 1 comes from this one. This is an odd degree, so this would be an odd asymptote. Same with this one, odd, so odd asymptote. And this one is even, so even asymptote. Okay? Horizontal asymptote, we look at the degrees. Degree on bottom is 4, degree on top is 2. So the bottom's bigger, so we still have y equals 0. X-intercept, so when the numerator is equal to 0, this is at negative 1. So we have negative 1 comma 0. Y-intercept, we're going to plug in 0 to everything. This one's going to be a little more involved. So we have 0 comma, and that's 4 on top. Negative 1 times negative 3 is positive 3 times 25. That's going to be 75, 1 over 70, or 4 over 75. If I did my math correct there. 4 over 75. Really ugly y-intercept, but we're just estimating. And there's no hole because nothing cancels out. So none on the holes. Once again, horizontal asymptote is 0. We do not need to check for crossing. The x-intercept already checks that for us. All right, so there's a few things we're looking at. First, we want to label our asymptotes. X equals 1, x equals 3, x equals 5. This is odd, odd, and even. Okay, odd, odd, and even. We do our horizontal asymptotes, which is here. And then we look at the x-intercept. X-intercept is negative 1, 0. So negative 1, 0, that's right here. And just like the polynomials we did at the beginning of the year, the factor that gave us this is going to tell us whether it bounces, crosses, or I think most teachers use slide. So this one is a degree of 2 at the x-intercept, which means it's going to bounce off of this. We'll put a little square there that says it's going to bounce. I think square is what they use. They don't, okay, I'm using a square. So this says it's going to bounce off of there. And we have a y-intercept at 0, comma 4 over 75. So this is 0, comma 1. 4 over 75 is really, really close to the x-intercept there. All right, so we start with the point we know. We take it and we go up to the asymptote. And then when we go the other way, we have to bounce off this point. So we bounce, whoop, and then we approach back. That's what we're going to look like. It's not perfect. We just want to show that we're touching it and coming back to the asymptote. Now the odd says we're going to go to the opposite side, so we go to the opposite side. And then look, we can't actually get to there because it doesn't say we cross, so we're going to go close and then go back the other way. Odd says we go on the other side, same thing here. We're going to go close, then go back the other way. Lastly is even. This says we go the same way. And so there's our full graph. Okay, so now we're starting to see more of these pieces coming together. We see the x-intercept, which says we bounce. We see the odds and evens all working together to give us this full picture of the graph. All right? Let's look at this one. Remember, we start by factoring, so this becomes negative x over x plus 1 and x minus 1. Vertical asymptotes is going to be x equals -1 and x equals 1. Horizontal asymptote, that's a squared on bottom, so y equals 0. X-intercept is just going to be 0, 0. Y-intercept is just going to be, plug in 0, 0, 0. Look at that. And no hole because nothing cancels. Once again, horizontal asymptote 0. We don't need to check if it crosses. The x-intercept already does that for us. From here, I want you all to pause the video and try and graph it yourself. I'll pick it back up in a second. All right, here we go. So we have vertical asymptotes at 1 and -1. So here's 1. Here's -1. Okay, we have horizontal asymptote at y equals 0. We have y-intercept and x-intercept at 0, 0. Now notice this time we do not have a point to start at. This one doesn't really tell us anything because it could go up to here, or it could go down to here, or it could go up to here, or it could go down to here. Doesn't really tell us much. So here's what we're going to do. We're going to pick a point somewhere either over here or over here, and we're going to plug it into the function. And that'll tell us whether it's above or below the x-axis. So let's say something over here. Let's say -3, and we're going to plug that in. So we have y equals negative times -3 over -3 squared minus 1. So that's going to be +3 over 9 minus 1 is 8. So +3 over 8. Well, that's estimating about right here. Okay? So that now gives us a point above the graph. Now we can follow our pattern. So go up, go down. This is the x minus 1 asymptote, so that's odd. So we're going to go opposites. Now here's the interesting part. This is x to the first power. That's a first degree intercept there, which means it's going to cross that asymptote. There we go. It's going to cross that asymptote and then keep going. And then this one is also odd. It's going to go to the opposite side and then continue on there. Okay? All right. All right, last one we're going to look at, and this is one that I want to look at because we do have to check whether it crosses. So we'll start with vertical asymptote. Actually, let's start with factoring. So we have x minus 3, x plus 1, x and x plus 2. So there we have it factored. Vertical asymptotes are going to be x equals 0 and x equals -2. Horizontal asymptote, this have the same degree, so our horizontal asymptote is y equals 1. X-intercept is 3 and 0, or 3 and -1, so 3 comma 0 and -1 comma 0. Y-intercept, we're going to plug in 0 for all those, and what we'll notice is there's no y-intercept because we get a divide by 0 on the bottom, so none. Hole is going to be none as well because nothing cancels out. If it does have a hole there, you just draw a hole on that point on the graph. But I don't think we'll have any on, like in my lesson, that's going to have a hole. There might be some on the homework. Now, notice, this time the horizontal asymptote is not 0. So we have to figure out if it crosses the horizontal asymptote. To do that, we're going to take this 1, and we're going to set it equal to our original equation, x squared minus 2x minus 3 over x squared plus 2x. And while this looks really ugly to solve, it should solve out kind of nicely. So we start by cross multiplying by x squared plus 2x times x squared plus 2x. Okay? So we have x squared plus 2x equals x squared minus 2x minus 3. And then notice the x squareds cancel, so that's nice. And we'll add the 2x to the other side, so we should get 4x equals -3, x equals -3 over 4. So at -3 over 4, it's going to cross the asymptote. So cross asymptotes. At -3/4, it's going to cross the asymptote. So we'll do that in a second. So let's start by labeling. We have x equals 0, we have an asymptote. X equals -2, we have an asymptote. Horizontal asymptote of y equals 1. At x equals -3/4, it's going to cross that horizontal asymptote. So we're going to put a little point there at x equals -3/4 that says it's going to cross there. All right? We have x-intercepts at 3, 0. And if we look, that's a first degree, so it's just going to cross. And -1, 0, same thing, first degree, that's going to cross. These are both odd. And so now we can draw. So we have this point that's not on the asymptote that we can use to draw. So we'll go toward the asymptote, toward the asymptote. Odd says it's going to be opposite, so arrow on the opposite side. And then now we have this point on the asymptote that we're supposed to cross through. So we'll cross through that point, cross through the x-intercept, and end up on the other side. And then another arrow for opposites, and we'll go right there. So there's our full graph. All right, so those are all the problems I'm going to go over today. If you have any questions, please ask your teacher. Let me know. Y'all have a great day.